Okay. So today we'll start from joining arrays. Right? We stopped before this yesterday. So let's start. So how to join different arrays? Let's go. Let's see one by one. Suppose I'm going to create numpy, import numpy as np, array one equal to np dot array one two three. Suppose this is one dimensional array, right? And array two, this is np dot array four five six. Okay. How do I concatenate this to 1D arrays? Okay, by row wise. So np dot concatenate array one comma array two. So the function is np means numpy because we have imported numpy with alias np, right? So np dot concatenate, this is the formula of array one and comma array two. So how it concatenates is row wise. So this is the row, this is the row, right? So 1 2 3 4 5 6. Let's execute this. So 1 2 3 4 5 6. This is row of array one, this is row of array two, and then it joins. Now say how can we concatenate 2D arrays, okay, along rows. Say I have array 1 equal to 1 2 3 4. This is the first row, this is the second row of first array. Array 2 equal to 5 6 comma 7 8. This is in list and this is in list. So this is the first row of second array and second row of second array. So how will it be merging is 1 2 5 6. This is the row concatenate, and then second row concatenate 3 4 7 8. So let's see np dot concatenate array 1 comma array 2. This axis equal to 1. Remember all of you, axis equal to 1 means row wise. Okay, axis equal to 0 means column wise. So axis equal to 1 we have mentioned here in concatenate function. So it will be merging row wise. So 1 2 5 6. This is first row concatenate, second row of first array, and second row of second array concatenate. So 3 4 7 8. Right. Now let's see how to merge with columns. Right? Columns means like 1 2 3 4. This is row, and these are columns, right? 1 2 columns, and then it will be 5 6 and then 7 8. So how to do that? Same arrays. So I'm not repeating. Array equal to np dot concatenate array 1 array 2 comma axis equal to 0. This axis equal to 0 means column wise. Okay. So see 1 2 3 4 and 5 6 and 7 8. So these are all columns, right? First column and second column. So column wise it got concatenated. Okay. Now you can do this concatenating or merging different arrays using different functions. There are different functions in Python like stack, hstack, vstack, etc. So let's understand how each of these functions work. Right? So here we'll use stack function. So array 1 equal to np dot array 1 2 3, array 2 np dot array 4 5 6. Okay. So we are going to use np dot stack array 1 array 2 and axis equal to 1. Axis equal to 1 means row wise, remember. Okay. So this is the first row. This is the second row of matrix 1. So 1 4 and then 2 5 and then 3 6. That's how it will get concatenated. So using stack function, if we mention x is equal to 1, it will be concatenating meaning row wise. So 1 4 2 5 and 3 6. And suppose we are using 8 stack. Okay, 8 stack actually um, 8 stack actually does the stacking. I mean, for say this is 1D array, this is 2D array. I mean, sorry, this is 1D array, this is also 1D array, second array. So it will be merging like 1 2 3 4 5. So it works similar to concatenate. 8 stack works similar to concatenate. np dot 8 stack. That's the formula. Remember, in concatenate function also we got this same output. So h stack is similar to concatenate. Okay. And if I want to stack along columns, so that is v stack. Okay. So if we want to concatenate along columns, that is v stack. Suppose I have 3 columns 1 2 3, and there are also 3 columns 4 5 6. So how it will be merged like 1 2 3 and then 4 5 6. It will maintain 3 columns only. It's getting concatenated using column wise. That function is vstack. Okay, so each stack is for row concatenation, vstack is for column wise concatenation. And there's one more function dstack. Okay, how it does is, so it takes like element from 1 and then 4, it is a row, and then 2, 5 row, 3, 6 another row. So that's called dstack. Okay, so these are different ways of concatenating arrays. Like we have stack, we have h stack, we have v stack, we have d stack, and we have concatenate. So you can use any one depending on your need. And if you ask me like, why do we need this concatenation or merging? Practically, suppose you have some data. Suppose you have two tables, data stored in two tables, different tables. Table one has like row-wise format, but table-wise has some say column-wise format. So obviously you need to concatenate properly, right? Sometimes you need to transpose the matrix, and after transposing, you need to concatenate or merge, so that you can create a final analysis data set which has same rows and same columns. That's the need of this stacking, restacking, age stacking, etc., or merging, etc. Right? Basically, in statistics or data science, we may have data files coming from multiple tables, multiple databases, right? And it could be in different structure. So to maintain the same structure in the final analysis data set, we need to do lot of data manipulation, data wrangling, right? So whatever I'm going to teach you, I'm teaching you right now. This will be or could be important to come up with your final analysis data set. Okay, that's the need. Now let's talk about splitting arrays. Okay, suppose I have np.array 1, 2, 3, 4, 5, 6. This is the 1D array. And if I want to split this array in two new arrays, so new array equal to np.array underscore split. That's the function. np.array underscore split array, this array, comma 2. Suppose I want to divide this one array to two different arrays. What will be the arrays? Like two different arrays, 1 to 3 is one array, 4, 5, 6 is another array. Let's see. Okay. Suppose I want to put in such three parts. This is two parts actually. Okay. Suppose I want to split this array into three parts. So what will be the arrays? New arrays. 1, 2 is one array, 3, 4 is another array, and 5, 6 is an third array. So 1, 2 is an 1, 2 is the first array, 3, 4 is the second array, 5, 6 is the third array. Because I have asked computer to split this original matrix to three parts. Okay. And similarly, okay, we could separate in, we can split in four parts also. But remember, Python takes care by the number of elements. I mean, say four parts. So ideally, there should have been 8 elements, right? 1, 2, 3, 4, 5, 6, 7, 8. But even if there are no four, and there are not 8 elements, but still Python takes care of that. How it takes care of that? So it moves like 1, 2 is the first array, 3, 4 is the second array, and remaining there are two elements, right? So it will divide. So 5 is the third array, single element, and 6 single element is the fourth array. That's how we split in four parts. So np dot array underscore split arr comma 4. If we execute it, and if we print this new array, it will be like 1, 2, then 3, 4, then 5 as a separate array, 6 as a separate array. Got it right? Because forcefully we are splitting in four parts. Okay. What will happen if I put 6 here? Can any one of you tell me? If I put 6 here, what will happen?
It will have array 1, 2, 3, 4, 5, 6.
Very good. See, array 1, single element, array 2, single element, array 3, array 4, array 5, array 6. Right? Okay. So now let's say can we access the elements of the splitted arrays? Obviously, if we can access the elements of the original array, obviously we should be able to access the elements of the splitted array also. Suppose 1, 2, 3, 4, 5, 6, np dot array underscore split array comma 4. We are splitting this array in 4 parts. So now I'll print like new array of 0. So this is new array of 0, new array of 1, new array of 2, new array of 3. So let's print it. New array of 0 will be 1, 2, because this is the first array. New array of 1 means 1 is index. Remember, 1 index means second position. So second array will be 3, 4. New array 2 index means third array. Third array is only 5 single element. And new array 3 index means fourth array. So fourth array is single element 6. Right? That's how it's getting printed. Okay, that's about accessing elements from the splitted array. Now say split a 2D array into 3 2D arrays. So far we have covered 1D array. Now let's split 2D arrays. Suppose np dot array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I split this np dot array underscore split, same function, but the structure of the matrix has been changed. Now it is 2D array. So array comma 3, I want it to divide by 3. How it divides is this is the first array, this is the second array, 2D array, right? And this is the third array. So 1, 2, 3, 4, this is the first array, 5, 6, 7, 8, second array, 9, 10, 11, 12, third array. Got it, right? Now say split the 2D array into 3 2D arrays. Okay, so basically here same function, only the difference is we have used extra column, 3 columns. So how it will get splitted? This is the first array, this is the second array, and this is the third array. Okay. The difference between the earlier one is just the columns have been increased. Like earlier 2 columns, now 3 columns. It works in the same fashion. Okay. Now let's say we want to split along rows. Okay. So we are creating say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So once we split row wise, obviously we need to give access equal to 1. Remember this always. So in np dot array underscore split array comma 3, I want to put in 3 arrays and access equal to 1. So what it will do is, remember like 1, 4, okay, 7, 10, 13, 16 will be the first array, 2, 5, 8, 11, 14, 17 is the second array, 3, 6, 9, 12, 15, and 18 will be the third array. Let's see. So 1, 4, 7, 10, 13, 16, 2, 5, I mean, it's coming from this one, 2, 5, 8, 11, 14, 17, 3, 6, 9, last array, 3, 6, 19, 3, 6, 9, 12, 15, 18. Okay. Okay. So similarly, you could use H split also. So if we use H split, it is also going to give the same output, like 1, 4, 7, 10, 13, 16. So what's the formula? np dot H split array comma 3 parts. np dot H split. Okay. So this is giving like similar to the last one, 1, 4, 7, 10, 13, 16, and so on. Now let's say, so those are all about splitting arrays. Now let's say we want to search something in a matrix. Okay. Uh, so let's say import a numpy as np array equal to np dot array 1, 2, 3, 4, 5, 4, 4. These are elements. Now I'll put like say x equal to np dot where array equal to 4. Okay, np dot where is a condition. It basically tries to fulfill whatever condition you pass as a parameter for this function np dot where, and wherever the condition applies, okay, wherever the condition applies, it gives the position. So np dot where means find the position wherever this condition applies. Find out the positions, index positions wherever these conditions applies. So let's see how it works. So array equal to 4. So it will first go to the first element. 1 equal to 4, false, right? So index won't be returned. 2 equal to 4, no, index won't be returned. 3 equal to 4, no, index won't be returned. 4 equal to 4, yes. So what is the index of this 4? 0, 1, 2, 3. So 3 will be returned because np dot where, right? And then it will again move to 5 next element. So 5 equal to 4? No. So it won't be returning the index position. This 4 equal to 4? Yes. So what's the index position? 0, 1, 2, 3, 4, 5. So 3, 5, remember. And it will move to the next element. So this 4 equal to 4? Yes. So what's the index position? 0, 1, 2, 3, 4, 5, 6. So 3, 5, 6 will be executed, will be printed because we are using np.where. np.where means it finds the index wherever this statement comes to be true. Okay, and this statement is coming to be true in this case, and this case. There's three cases, and for these three cases, the index position is 3, index position is 5, index position is 6 because 0, 1, 2, 3, 4, 5, 6. Python index always starts from 0. Okay, so good. I hope you have understood now. Clear, right? You can write in chat box. Okay, good. Now, okay, good. Sounds good. Now say, let us find the index says wherever the values are even. So how to put that condition? Array equal to np dot array 1, 2, 3, 4, 5, 6, 7, 8. X equal to np dot where, same condition. I mean same function. We want to find out the indexes, but the condition is different. What's the condition now? Condition is ARR modulo operator 2 equal to 0. So this gives remainder. ARR modulo operator 2. This gives remainder. Wherever the remainder is 0, that index will be printed. So first, let's go here from here. 1 percentage 2 equal to 0. No. So it won't be printed. The index position won't be printed. 2 divided by 2. Is it having the remainder 0? Yes. 2 can be divided by 2. So remainder equal to 0. So index position is 0, 1. 1 will be returned. 3 divided by 2. Remainder equal to 0? No. 4 divided by 2. Remainder equal to 0? Yes. 4 can be divided by 2. That's why. So remember 0, 1, 1, 2, 3. So 1, 3. Then 5 can be divided by 2. No. So index won't be returned. 6 can be divided by 2. Yes. So index will be returned. So 0, 1, 2, 3, 4, 5. So remember we got 1, 3, 1, 1 index, 3 index, 5 index. And then it will move to here. 7 divided by 2. No. 8 divided by 2. Yes. So index will be returned. So what is the index of 8 value? I mean value 8, 0, 1, 2, 3, 4, 5, 6, 7. So we got indexes like 1, 3, 5, 7. Let's see. Okay, we got it 1, 3, 5, 7. Right? Did you get the logic? The logic we changed and it gives us the corresponding indexes. Similarly, if the values are odd, same thing like np dot where. What we will do is if some values are odd, what will be the remainder? Can you ping me in chat bot? If some values are odd values, odd numbers, and if you divide by 2, what will be the remainder? Just quickly, you can ping in chat box. Yes, absolutely, Apurva. Row, yes, 1. So we will change the condition. Yes, Roshni, yes, 1. So we'll change the condition to 1. Okay, so array divided by 2, remainder equal to 1. Only we'll change the condition. And now I'm not repeating because so far you know how it works. So 1 divided by 2 equal to 1. Yes, because the remainder will be 1. That's why 0 position. 2 divided by 2 equal to 1. Remainder? No. Because 2 can be divided by 2. So the remainder will be 0. 3 can be divided by 2 and remainder 1. Yes, remainder 1. So 0, then 2, and like this it will move. So 2, 3, 4, and 5, 6. Right. So we'll get like 0, 2, 4, 6. 0, 2, 4, 6. Okay. Now let's move to sorting arrays. Hope it's clear to all of you because the explanation was pretty good, right? And you understood the logics. So sorting arrays like import numpy as np, array equal to np dot array 3201. The function is np dot sort. np dot sort. If we put array, np dot sort which object you want to sort it. So np dot sort, I mean numpy array, right? So array, and it will sort like 0 1 2 3, 0 1 2 3. Okay. Similarly, you can sort alphabetically also, or strings also. Okay. Suppose I have an array like np dot array banana cherry apple, so it will be sorting like apple, banana, and cherry. np dot sort array, it will apple, then banana, then cherry, right? Sort a boolean array, that is also possible, like true, false, true. So the lowest value is false. Okay, false, true, true. np dot sort array, this boolean array, it will give like false, true, true, because false is the lowest value. I mean, false is zero and true are ones. Okay, boolean how it works is false is zero and true are one. Now let's say we are going to sort a 2D array. 2D array also you can sort it. So 2D array, how it's getting sorted is row. I mean, it sorts the elements of row wise. So this is the first row. So 2 3 4, and say 0 1 5. Okay, so np dot sort array. So 2 3 4 and 0 1 5. So let's see, 2 3 4 and 0 1 5. Right. Okay, so that's about sorting. 1D array, 2D array. Both I hope you are clear now. Okay. Now say we want to filter arrays. Okay. So filter based on some condition. Okay. Okay. Now let's see how it works. So import numpy as np, you know it. Array equal to np dot array 41, 42, 43, 44. Now we are going to create a boolean array x equal to true, true, false, true. And we are going to create a new array equal to array, and then putting this condition. So x is, I mean, array, then if you are putting something, then it works like condition or the element or the position, etc. So this is a Boolean condition, remember. True, true, false, true. So what will happen is, wherever there are true values of this Boolean array, those values will get printed, because I'm putting array. I mean, how it works is, take elements from array wherever this boolean seems to be true or false. This works like that. Okay, so array of x means wherever is true, those elements will be printed. So 41, 42, 44. Let's print new array 41, 42, 44. Got it? Okay. Now let's say we want to create a condition, customized condition, I mean based on some loop, etc., or if condition, etc., and we'll try to filter arrays. Okay, wherever there is greater than, wherever the elements are greater than 42. So how can we do that? Say array equal to np dot array 41, 42, 43, 44, and initially we'll create an empty list. Okay, so this we are showing you how to do this, but this is a complicated step. There is a shorter step also. I'll show that also. So filter underscore array equal to and create an empty array, and then what we are going to do is, for element in array, or you can put I also. Remember, this value you can give as per this name, you can give as per your choice. So I could use like for I is etc. Okay, for element in array, then we are going to put a condition: if element greater than 42, if element greater than 42, then filter underscore array dot append equal to true. That means append, you know, right? So far append is like appending this new value to the list or array. Okay, so this is the list actually. So filter dot array append true. So wherever there are elements which are greater than 42, true value will be there appended, and else filter underscore array dot append false. So false value will be appended if some values are not greater than 42. So what will happen is this, first it will check this element. So this element is greater than 42. No, so this line won't be executed. Then it will move to this condition else. So this is else condition is true, like 41 is not greater than 2, right? So then the value will be false. So false value will be here. Then it will move to this element 42 greater than 42. No. So again false. 43 greater than 42. Yes, the true. 44 greater than 42, yes, then true. So false, false, true, true. The values will be for filter underscore array, because we have appended the values true, false to this array. So if you print like filter underscore array, the values will be false, false, true, true. Now what we are going to do is we are going to create a new matrix, new array equal to array, this original array, of this condition filter array. Now you have a condition filter array. So what will happen is, can anyone of you tell me what will be the values for new array? The logic that I explained, and if I put this filter underscore array condition for new array, what will be the values that it will be printing? The new array. You can ping in chat box. What will be the values for new array?
False, false, true, true.
No, the values. See, when I'm talking about from array, it will be giving me the original elements. So what will be the elements of new array? That you said
43,
about
44,
condition.
43, 44.
Yeah, yes, excellent. So print filter array, print new array. So let's see. Okay, see false, false, true, true, because 41 is not greater than 42, so false. 42 is not greater than 42, so false. 43 is greater than 42 as per these conditions. These conditions. Okay. 43 is greater than 42, so true, true. So my filter array will get appended with the values false, false, true, true. So which is clear from this line output. And then I mentioned array and take filter underscore array boolean array as a condition. So to fulfill this condition, false, false values won't come. So false, false values means false is 41, false is 42. So these values won't come. True values will come only. So this is also true. This is also true. So 43, 44 values or elements will be stored in new array. That's why if you print new array, the values will be 43 and 44 only, and not 41, 42, because again it's coming from this condition. Okay, got it? Okay, now similarly, if I want to say return only the elements which are even elements, so how can we do this? Hope you have understood that we need to change some condition here, right? What is the condition? Can any one of you tell me? If I want to check the even elements, what will be the condition? You can ping in chat box. What will be the condition? Quickly. I mean, what condition can give you even elements? I've already explained you some examples. You can relate to those earlier examples. Where is a number is even? I mean, you can, if you find that logic, you'll be able to. Yes, excellent, excellent. Sai Sunit, Roshni, yes. Remainder equal to 0. You are right. So import numpy as np, array equal to np dot array 1 2 3 4 5 6 7. Filter array equal to this blank list. Again, suppose I'll move ahead with the earlier logic, like for element in array. If element percentage 2, I mean remainder equal to 0, then I will put true value append to this filter array. Otherwise, I'll append false value to this filter array. So based on this condition, you know that filter array is going to create true false boolean array, which will be false here, false here, true here. So false, true, false, true, false, true, false. Right? Filter array will be false, true, false, true, false, true, false. And if I want to access the elements array, and then based on this filter array condition, which values will be printed? Can any one of you tell me what of the elements will be saved in new array? What are the elements?
246.
Yeah, very good. So print filter array, print new array. So false, true, false, true, false, true, false. As I explained to you, and the values will be returned as 246 because these are even elements, and these even elements are coming from this condition, right? Okay, now the simpler way. This is the complex way. Don't follow this approach. Okay, in any coding language, you'll choose the least effort, least effort. Whatever function or code takes least effort and less number of lines, you'll choose that. How to do that without using for loop? Here, like say import numpy as np, array equal to np dot array, same elements 41, 42, 43, 44, filter underscore array. Directly we are putting. See, there's so many lines we are skipping. So many lines we are skipping, and we are putting a condition like filter array equal to array greater than 42. That's what's perfectly like earlier. Array greater than 40. So this array greater than 42. So how it works is it goes through all the elements and then checks 42 greater than or not. So false, false, true, true. Automatically it will be generated for this filter array. Okay, then new array equal to array filter array, print filter array, new array. So false, false, true, true, 43, 44. Right. This is pretty interesting, right? Without using for loops and those conditions, directly it's coming. Okay, now same approach. How can we find the even elements? Can any one of you tell me? And can you can find thing in chat box? What will be the condition
array
if I want to
percentile
find out?
2 is equal to 0.
Yes, excellent.
Uh,
Yes, you are right. So important numpy is np array dot numpy is to and then filter underscore array equal to, right? This array percentage of two and not percentage modular operator equal to 0. See, we can directly pass it and we can assign to filter array. That's the best part of Python and those things, right? We can put the condition here directly. ARR divided by 2. If the remainder equal to 0, then take the values in filter array. So automatically it will put like false, true, false, true, false, true, false. And then I'm accessing new array equal to array, taking elements from array based on this boolean array, and it will be giving me the values of 2, 4, 6 because false, true, false. So true values I'll get. So true, true, true. So 2, 4, 6. Let's see. False, true, false, true, false, true, false. Okay, and 2, 4, 6. Got it? Hope it is clear to all of you. Now let's move to arithmetic operations for us. Okay. So import numpy as np array 1 equal to np dot array. This is the array 1, 10, 11, 12, 13, 14, 15. Array 2 to np dot array 20, 21, 22, 23, 24, 25. New array equal to np dot add. Okay. So how it works like np dot add means addition, and it works similar to like array 1 plus array 2. I'll show you both the output by executing the same code in the next line. So print array, so what it will do is 20 plus 10, 30, 11 plus 22, 32, and then 22 plus 12, 34, and so on. So 30, 32, 34, 36, 38, 40. So this element plus this element, and so on. And if you execute this same line, array 1 plus array 2, this will be also same like np dot add. So np dot add is also same, and this array 1 plus array 2 is also same. Let's see. 30, 32, those things are okay. Now similarly, if we want to subtract, so np dot subtract, and that will work like array 1 minus array 2. So np dot subtract array 1, array 2, and then this works like array 1 minus array 2. Let's see. Np dot subtract. Remember this formula. Rest are same. Rest is same. Array 1 minus array 2. This also works like this. Okay. What about multiplication? Multiplication is np dot multiply, and this works like array 1 star array 2. Star means multiplication in Python. Okay. So let's see np dot multiply. So 20 into 10, 100, and so on. Sorry, 20 into 10 is 200. 10 into 10. Okay. It's not 10 into 10, 20 into 10. So 200, 420, 660, 920, 1200, 1500, and array 1 star array 2. Same like np dot multiply. This will also give same output 200, 420, 660, and so on. Okay. If you divide np dot divide, np dot divide. Okay, that's the formula, and it works like array 1 slash array 2. Slash means divided by. So let's see the printing. So 10 by 3. Okay, 3.33. So this is quotient. Okay, not the remainder. 10 by 3 and then 3.333, 20 by 5, 4, 30 by 8, 30 by 10, 3, etc. Right, and this works similar to array 1 slash array 2. So array 1 divided by array 2. Okay, same outputs you'll get, right? Okay, now if I want to calculate the power, to the power formula is np dot power or double star. Double star is like equals like, so x double star y means x to the power y, right? So let's see. Np dot power function will put array 1 to the power array 2. Okay, let's see what's the formula. Array 1 to the power array 2, that means 10 to the power cube, so 1000. 20 to the power cube means this one. And array 1 star array 2 will be same to this np dot power, right? Let's see. Yes. Now say I want to return the remainders. Okay, if I want to return the remainders, I can do it using np.mod function. Okay, np.mod function. So np.mod array 1 array 2, this will return the remainders. So 10 divided by 3 remainder is I mean the quotient is 3 and remainder is 1. 20 divided by 7, the quotient is 2 and then remainder is 6, right? And 30 by 9, quotient is 3 and remainder is 3, right? And so on. And this works similar to like array 1 modulo operator array 2, because by this operator we get remainder. So let's see whether the outputs are same or not. 1 6 3 0 0 27 outputs are same. Okay, return the remainder using another function np dot remainder. So this was np dot mod function. You could do this same thing by using np dot remainder function also. So let's see how it works. 1630027, which is same output as earlier, right? Now suppose I want to return quotient and remainder both. What's the function? Function is div mod. np dot div mod will give me both the quotient values also and the remainder values also. So np dot div mod array 1 comma array 2, and we are storing the outcomes in new array. We are printing new array. So let's see how it works. 10 by 3, the quotient is 3, but the remainder is 1. Okay, so quotient will be this array and remainder will be this array. 20 by 7, quotient is 2, remainder will be 6. 30 by 9, quotient is 3, remainder is also 3. And so on. 40 by 8, quotient is 5 and remainder will be 0. So 5, 0. And then 50 by 2, quotient will be 25, remainder will be 0. 60 by 33, quotient will be 1 and remainder will be 27, right? Because 60 cannot be divided by 33. So the quotient will be like, 33 will come out here, 1, and then remainder will be 27, right? So return the absolute values. np, suppose I have np dot array equal to -1, -2, 1, comma 2, comma 3, comma -4. This function np.absolute gives me the absolute values of these elements. So 1 2 1 2 3 4 it will come, right? So let's see. 1 2 1 2 3 4. Okay, now that's about all the outcomes, some arithmetic operations. Now let's move forward with matrix operations. Matrix operations from mathematics. Let's see how it works. Suppose I want to transpose a matrix, so it just x dot capital T will transpose the matrix. So x equal to numpy dot array. We are taking 1 2 first row, 4 5 second row. This is a 2D array. So print the original matrix, print of x, and print the transpose matrix, the x dot capital T, that will transpose it. So like new initially these were row, right? So it will get converted to column. So 1 2 will be column and 4 5 will be column. Earlier it was row, 1 2 was row, 4 5 was row, but now will get converted to 1 2 as column, 4 5 as column, second column. Let's see. Okay, 1 2 4 5 was the row original matrix, and it will be converted to columns, 1 2 column and 4 5 column. Right? So that's how we can transpose the array over x dot t, and addition of two matrices. I have already shown you like x equal to 2D array. I have shown you for 1D array. These are for 2D arrays. So x equal to np dot array. This is 2D array. This is 2D array. Second 2D array. So x numpy dot add function will give the addition of x plus y. So what will be the values? Like 1 plus 7. Okay, 1 plus 7 8. Then 4 plus 9. 1 plus 7 8. Right. So let's see. 1 plus 7 8. 8 plus 2 10. 9 plus 4 13. 10 plus 5 15. And similarly, subtraction like numpy dot subtract or np dot subtract. Here we are using numpy because I also imported numpy. Import numpy. You could use np also because we have imported numpy as np also, right? So np dot subtract x comma y. This will deduct. So 1 minus 7 minus 6, 2 minus 8 minus 6, 4 minus 9 minus 5, 5 minus 10 minus 5. And multiplication, np dot array, np dot array, np dot multiply. So how it works is like it is not dot product. So multiply is like 1 into 7, okay, then 8 into 2, then 4 into 9, and then 5 into 10. So 1 into 7 is 7, 2 into 8 is 16, 4 into 9 is 36, 5 into 10 is 50. Okay, and similarly division works. np dot divide. Okay, numpy dot divide if you have called numpy directly, or np dot divide if you have called numpy as with alias np. So np dot divide x comma y. right? So 1 by 7 this value, 2 by 8 this value, 0.25, 4 by 9 is 0.444, and 5 by 10 is 0.5, right? Now let's talk about dot product. So dot product, how it works. So these are the arrays. Okay. So 1 into 7. Okay. I mean, and 2 into 9. Okay. So 7 plus 18 is 25. So 1 into 8. Uh, 8 and say 2 into 10, 20. So 8 plus 20 is 28. 4 into 7 plus 5 into 9, 73. 4 into 8 plus 5 into 10 is 82. Okay. That's how dot product works. Got it? Now let's say we want to find row sum and column sum. Okay, we are going to define this array, np dot array 1, 2, 4, 5. Ordinal matrix we are going to print of x and say we want to find the square root of the matrix. So np dot sqrt, this is the function of square root. The square root of all the elements it will print. And if we put np dot sum of x, it gives summation of all the elements 1 plus 2 plus 4 plus 5, 3, 7, 12. So the value will be 7. And row wise summation np dot sum x comma x is equal to 1. Remember x is equal to 1 is for row wise. So that will give me row wise summation. And column wise summation, if you put x is equal to 0, it will give me column wise summation. And I printed all the values. So let's see how it works. So this is original matrix square root. It will square root all the elements. The summation of all the elements, as I mentioned, it will be 12, 12. The row wise summation 3. So row wise summation 3, 1 plus 2 is 3, 5 plus 4 is 9. So 3 comma 9, and column wise summation 1 plus 4 equal to 5, 5 plus 2 equal to 7. So column wise summation 5 and 7. Right? Got it? Yes. You can write in chat box if you have understood clearly. Okay, good. Now let's say we want to show some decimal points. So np dot truncate. So this will truncate the values. Okay, like it will give say -3 and 3, right? It will truncate to the nearest integer. I mean the lowest integer. Okay, so -3 and -3 and then 3, right? np dot trunc, that function np dot fix. Np dot fix will give me like -3 and 3, right? Np dot around will give me the like say to third decimal places or say two decimal places, right? If I put say two decimal places, so that function is np dot around. So 3.17, 3.17, because you know anything which is more than 5, the first, I mean, the earlier position gets increased by 1, right? So 3.17. And np dot floor is like giving me the lowest integer, so -3. So it will be converted to -4, and then 3.66 it will be like 3. Okay. So the less than, I mean, one digit less will be the output. So -3, so you know -4 is less than -3, right? And 3.6767 is 3. Okay, so that's the output of np dot floor. And what is the output of np dot tail? So ceiling, so -3.166, 3.667, it will give me -3 and 4. Okay, got it? So these are the differences between floor, sail, around, and fix, as well as trunk, right? We have so many options to trunk it to get some decimal points. Now the last part is say random number. Okay. So I'll explain you when I'm taking statistics class or and probability class what is a random event, random experiment, etc. But at this point of time, remember random number is anything whose output is not pre-known. I mean, is not known in advance, and the outputs are random. Random means it is not fixed. There are so many chairs. Okay, I think it is all answers of my questions. Okay. Now, random number is a number which whose outputs are not known in advance, and it can give a turn up to any figure. So, if I say put 100 random numbers, it can give any random number from 0 to 100. Okay. So, what is the syntax? From numpy import random. So we are going to use random library, random function from numpy library. So from numpy, the code to to import a specific function from a library is from numpy import random, and we are going to use that random. X equal to random dot rand int. Rand int means rand int means taking integer random numbers of 100. Not of 100. I mean take 100 random numbers, and if I want to print say from 0 to 100, we are going to take random numbers. So 43. If you want to run again, it will give you a different random number. If you run again, it will give me a different random number. So the total, I mean, the possible outcomes is known to you, but the exact outcome is not known to you. So this is the exact outcome. If you print again, it will give me another number. So 31, right? So this is called random number. And suppose here we drew a random number from 0 to 100, but here let's say we draw a random number from 0 to 1. So that function is random.rand. Okay, this function gives me random number from 0 to 1. So from numpy import random x equal to random.rand print x. If you print it, every time the value will be changed. So 0.4396, check it. 0.6211, check it. 0.46, again last time 0.5960 or 5961, right? Okay, that's about random number generating. And let's say we have a 1D array. Okay, and say we want to draw 5 random numbers. Okay, so x equal to random dot randint 100. Okay, from 0 to 100, size equal to 5 means I want to draw five digits, specific digits from 0 to 100. So how it works? 72 initial output, say at the run, I mean first run, this one. If I run it again, the values will be changed because I put rand in, right? Random integers. Say earlier it was 72, so 11, 87, 14, 59, 18. Again it will change. And last time again it will change. I mean if you keep running, it will change, keep changing. Okay, because this is a random number. Output is never fixed. Okay. Now say generate a 2D array. 2D array, how can we do it? Random dot rand int 100, 0 to 100, and then size equal to 3 comma 5. Here remember size equal to 5 we mentioned, but here it's a 2D array. So 2D array means 2 parameters. If you remember, 3D array means 3 parameters, etc. So size equal to 3 comma 5. So 3 rows and 5 columns. What I want to do is I want to draw random numbers from 0 to 100, and then uh, I want to create 3 cross 5. I mean 15 random numbers and put it in a 2D array, 3 rows, 5 columns. Let's see. So 3 rows, 5 columns. Initial outputs for the first run is from the first run is 395, 63, etc. If you run it again, the values will be changed, and I'm not running anymore, so you have understood fully. Okay, now say earlier we used integer, right? Now we'll use a float. So random.rand, you already know, right? Say 0 to 100, we want to put like, so this is how it works. Is random.rand is the random number from 0 to 1, right? So 0 to 1 random numbers you want to draw 100 times. So print of x. So you want 100 numbers from 0 to 1. So 0.88 should see these are 100 numbers. All are from 0 to 1. If you run second time, remember, okay, 0.88 to 1. Remember this value and this value 0.8758. So now let's see the values. Entire values will be changing. But just to remember, 0.95, 0.91, these are purely different from the earlier output, right? Similarly, all the values will be different. It will not exactly match, and it is mandatorily it will be different. Okay, that's how it is random number. Okay, now say we want to draw float rank random numbers 0 to 1, and then we want to get say 3 cost 3 comma 6. That means 3 rows and 6 columns. Okay, let's see. Yeah, so 3 rows and 6 columns. So what it is doing is it is taking 18 elements because 3 cross 6, and all random numbers will be from 0 to 1. Okay, remember these values 0.3836, 0.3305, 3836, 3305. If you run it, see 3253465, which is purely different from the earlier values All the values will be different. Okay. Now let's say we want to draw some random number from the matrix itself. I mean, we want to shuffle from the elements of the matrix itself. So from numpy import random x equal to random dot choice from this array, or say from the specific list of values. So I am telling computer that okay, give me a choice from these values, only from these values 3579. So give me a choice, random choice. Let's say okay, this is like a lottery, right? I mean, like yeah, this is like a lottery. What you do, like say your 1,000 customers or say 1,000 people who say purchased lottery, you just say give here the lottery numbers. Okay, suppose 3 is the lottery number, or say 003, or say 1003 is the lottery number, and so on. Maybe let's put some valid lottery number. That will be interesting, right? Suppose say 2001 is the lottery number. Say 3210 is the next lottery number. Say last 4 digit, and say this is for say third prize kind of, maybe. Okay, just for example, say 5650, and say for 1112 or something like that. Okay, and I'm asking computer, okay, give me a choice. Who is my one fourth award owner? So fourth award owner will be, so waiting. 1, 2, 3, 4, 5, start. Okay, so it's going to give me, this is the lottery owner 5650. Got it? Right? Clear? You can write yes in chat box if things are clear. Okay, good. Now let's say generate a 2D array, okay, from the choice of these values only. I mean, not from 100 integers, 0 to 100, not from 0 to 1, but I want to create a 2D array of 3 rows and 5 columns only from these elements. So what will be the script? X equal to random dot choice, because that's how I can select elements from a specific list 3579, and then I'm telling computer, okay, convert these numbers to a 3 cross 5 matrix. So 15 elements will be drawn from this with replacement, because these are only 4 elements, right? Obviously I need to get maybe more than 3. I mean, 3 will be 1, it could be more than one time, it could be more than one time, it could be more than one time, it could be more than one time. So let's see. So 33933 73 733 375 Okay, this is not fixed. If you run it for the second time, it will be changed. Values will be coming from 3579 only, but the rows and columns will be changing. So 333 555 355 735 etc. If you run for the last time, so 577 973 953, these are columns I'm talking about, 537 597. Okay, now let's say okay, so this is basically a random number but with some probability. So probability I'll explain you in the statistics class. As of now, remember, probability is nothing but the total number of favorable cases by total number of possible cases. Total number of favorable cases by total number of possible cases. Suppose I throw a dice, what are the total possible values? 1, 2, 3, 4, 5, 6. And if I want to see, okay, what is the probability of getting outcome 1? So outcome 1, that means I have only one favorable case, because only one output is there, right, in a dice. So that's why 1 by 6. 6 is total number of outcomes. So probability is nothing but favorable number of cases by total number of cases. Okay, here I am defining that okay, 3 value will have 0.1 probability. That means 1 by 10. 5 value will have say 0.3 probability, 3 by 10. 7 will have probability of 0.6, and 9 have probability of 0.0. So 9 will never happen. So if I run this, you will not get 9, because 9 has probability 0. Okay, and suppose I draw 100 random numbers, the way it will be generating the outputs, that I mean, suppose 100 out of 100, you will get 10 times 3, because 1 probability, 0.1 probability, and 30 times 5, and almost 60 times 7. So if you check it, most probably you'll get 3 10 times, 5 30 times, and 7 60 times based on this probability. Okay, now let's uh, let's draw. So 100 random numbers from 3 to 9. I mean 3 5 7 9, these values, but 9 won't ever come, because It is 0 probability. Okay, let me change the probability. Okay, let me put 0.4 here. Okay, and 0.431, so 2. So remember, probability value, total probability must be 1. Okay, that's why I was checking the total sum of this, and then I decided by the probability for this. So this total probability value must be 1. So 0.1 plus 0.3 plus 0.4 plus 0.2, if you sum it, it will be 1. Okay. Now 9 will come. Interestingly, earlier 9 was not coming because probability was 0. Now I have changed the probability. So now how it will come is like 10 times 3 will be there. I mean, most probably 30 times 5 will be there. 40 times 7 will be there, and 20 times 9 will be there. So now let's print, and 9 will be coming for sure. Okay. See, 9 came. Earlier, if you remember, 9 was not there. Okay, now everything is coming. 3 also coming, 7 is also coming, 9 is also coming, 5 is also coming because they have different probabilities. Okay, got it? Interesting. Good. So now let's say 2D array, same thing. We want to define the probability values. Suppose, okay, here let's see first whether 9 is coming or not, and I want to convert it to 2D array. 3 cross 5, so 3 rows, 5 columns. If I print it, it won't be generating 9 because 9 has probability 0. So it will be taking from 3 to 357. Okay, so 5 7, so this is random, right? So 3 did not come. So if you run again, 3 may come, because and 3 is also having less probability, right? So 3 is not coming. So still, yes, now 3 came, right? But check for the last 3 outputs, 9 never came. Now let me change the probability 0.4 and say 0.2. Okay, now 9 will come, and it will come randomly. This is random, so if you generate again, see 9 here, everything is coming 3 5 7 9. Got it, right? Okay, you can write in chat box yes if you have understood clearly. Okay, good. So permutation, you know permutation, all of you, permutation combination, right? Suppose I have a matrix like a 1 2 3 4 5, and I want to shuffle it. Okay, random dot shuffle of array. So like it will be shuffled 1 5, and shuffled means like it will take different permutations of these values. So 1 5 3 2 4. If I 1 4 5 3 2, sorry, sorry, it's feeling cold now. If I run it again, 1 3 5 2 4, if I run it again, it is shuffling and it's giving me different permutations randomly. Okay, now say I want to get a random permutation from this array. So random dot shuffle is also one command, random dot permutation is also another command. It gives the permutation, it shuffles actually. So this gives the permutation 1 2 4 5 3 and so on, 4 3 2 1 5, and that's all. So that's all for today's class.